Hey everyone, I'm back. I know it's been a while. Today we're going to be talking about Kubernetes secrets, and it's something that's really hard to do. Managing them, you're either just going to hard code your secrets, you're going to have to manually manage them, add a manual process in, and it's a huge pain. You might have to run commands one at a time, or you can make a script. And the best way to do it is using a secret management system. And the pain of that is you have to deploy it. So, what we're going to do in this video is we're going to go over these secrets. We're going to start with a really bad example, and then we're going to improve it, and then we're going to improve it even more and make it easier for you in the future to add secrets and manage them. So to do that, we are going to start off with just a simple Kubernetes secret, and then we will go into how you can handle that with the command line or YAML. I'm not going to get super deep into making secrets. It's just about managing secrets. So I'm going to assume you have a Kubernetes cluster already, for one. And the second one is that you know how to create secrets and you're kind of familiar with using them. And then from there, we're going to make a simple bash script. And that bash script is going to talk to a HashiCorp vault. And then from there, with the vault, we are going to move it into external secret operator and have everything declarative through YAML. And you can just easily add them into your projects in any namespace, and it will get secrets from Vault using the Kubernetes auth method. So here I have some Kubernetes auth method. This is the one we're going to make. We're going to create this read-only role. And then also we're going to make some policies, and we're going to use Terraform to create this. You don't have to use Terraform, but I'm going to because you can make some modules and make things really nice. So let's not waste any more time. Let's go ahead and jump right in. So I wrote this doc. It's kind of a blog post on my blog. You can go to devbuilddestroy.com. Go to blog. It's this first one. And we're going to start with the bad example. Let me make this bigger for right now. So, yeah, for this bad example, this is how most people are probably doing it. You're going to either just throw it in a YAML file, hard code it, be done with it, or you're going to use a CLI command. So I have some pros and cons. So it is a lot simpler to do it this way. I would say this way is easier than this way, than the CLI way. But you're going to expose your secrets if you save these in a Git repo, which you should be doing. Whereas this one, you won't expose your secret in a Git repo, but then there's no version control. I can't roll the secret back. I can't do anything. I just create it, delete it, it's gone. It's updated. So we want to have some version control. So these two methods kind of suck. Yeah, I've been managing apps on my cluster for a while, and I did start out doing it this way. And then I kind of moved to this way. And every time I needed to make a change, update a password, or do something new, it just was a big pain in the ass. So how can we level this up? Well, let's turn up the heat. We can use Vault. And we can kind of do a scripting approach. So let me zoom in on this. So you can do this very simple. You do your Vault address, and then you authenticate some way. So I'm using the OIDC method because I'm going to do it, but you could also just set your Vault token. Same way this, Vault underscore token, and then set your Vault token, and it'll work. And so it'll get this secret at this path stored in this creds variable locally. It's not going to export it. There's no export. And then we're going to just delete this secret in case it already exists. And then we're going to create the new secret. We're going to do it from this literal. We'll get the access key and secret access key. And I use JQ, so I'll echo out the JSON format. So if you look here, we're putting it in format JSON, right? So that allows us to use JQ. And then we can get the raw value out using this path to the secret value. And then it's going to store it in those values and update the secret. And this is a lot nicer because I can save this script in a Git repo. And I was doing this before, I can show you. So let's go to my Loki. And I literally was using this. I updated the script a little bit for the guide. And I was able to update it to this. So instead of having to run this manually, in the future, we're going to get it here. You can save this in your repo. You can use it in a CI pipeline. But it's a little kind of clunky, you know, and it's probably not as intuitive. If you want to kind of manage the way things deploy out, you have to know you have to manually run this first and create the namespace before you even deploy any of these resources. So it is a step up. You are adding some security, and you can kind of make it dynamic. You can share the script with someone else and they can run it. And as long as they have access to the Vault resources and the Kubernetes resources, then you're good to go. You can go ahead and just give it to them. They can run it, update it, manage it with you. A little easier to rotate. You would just go into Vault, go to your secret engines, and then you would go to here and make sure that secret exists. Easy, done. But you're going to spend a little time. You have these manual steps still. And we're trying to get away from these manual steps. And since we want to move away from these manual steps, but we also want the ease of this. So the ease of declarative, security, no manual steps. That's our goal. So how can we do that? Let's use the external secret operator. So we're going to do it like the pros do. And this sounds like a lot more than it really is. There are a bunch of things we need to set up, like service account and token. We have to do a cluster role binding for that. We have to create a long-lived service account token for Vault to talk to our Kubernetes API. Requirement, Vault must be able to access your Kubernetes API. So mine is running on, it's just in a single node Vault in a container running on some VM somewhere in the same network as my Kubernetes cluster so they can talk to each other. That's available. So this is a requirement. Also, I do believe I have a Vault guide. If you look in here, you can click on this link. I have a single node Docker install that you can go through on this. And I have this Docker toolkit project. It'll create your own certificates and everything. So you can have everything that I have, just follow this guide. So make sure that's deployed because now we're going to start using it for real. So let's get into it. So we need to make this service account. So I'm using Argo CD to manage my resources. So I have this project right here, ESO for external secret operator. And I split it up into system and resources. So if you go into the system, I have the Helm chart. So that's how we're going to deploy it. But first, we need to make this service account. So we're going to make one called token reviewer. You can ignore these because I actually don't need those. I was playing around with it. So we're going to give it that name, and then we need to do a cluster role on it because the way we're going to do this is I just wanted to make one service account that can authenticate with Vault and that any of these, they call them secret stores, can use. So this service account will just kind of handle authenticating tokens, and any mount can use it in any namespace. The mount or the secret store, sorry, not mount, the secret store is where you will say what path it's going to, what secret mount you're using in Vault. So it's just for validating tokens. So I'm going to give it some access here to some different API groups and different things it needs. And then we create a cluster role binding. A lot of tongue twisters in here. And we just add the Vault token reviewer to the binding, which I think actually, oh yeah, so had a little brain fart there. So we're going to bind this role Vault Token Reviewer to our Token Reviewer service account. And then that's done. And then the next thing we need to do is make the token. Very simple. Just create this. We're going to create the Token Reviewer token. And then it's going to create a long-lived secret so we can access this token and use it. Then we create the Helm chart. So I'll show you my setup for the video, but I did create this secrets project that I'm putting everything in, but I just do a reference to my Git repo where I'm holding these files. And then I'm referencing my values YAML, which this is all the default. I really wanted to just play with this Bitwarden SDK server, so you don't necessarily need the values. It should be okay just with a regular install without changing anything. I think this was the only setting that I tweaked out of all of these. So no worries on that. And then from there, it's going to grab the external secrets operator chart. We're going to install this version, 0.11.0. And then I'm going to use that values file as a reference. So it references the repository. So it's going to kind of look here at the repository, then go into system values.yaml, and then that will handle that. And then I'm going to just give it this release name. And then I specify I'm using the external secrets chart, and it's at this path in the Helm chart repo. So this took me a little bit to figure out when I started using Argo CD to manage my Helm deployments, but you can kind of use this as like a cookie cutter template. But to get this to work though, I have an Argo CD sync repository, and I have some projects in here. So if you want to recreate that secrets project, I just allow these source repositories, I allow them to go into these namespace. You can restrict it further if you want to, but I just wanted to play around with the app projects. So it's kind of an unnecessary step. Feel free to just leave it as default. And then I create this application, and I do it in a sync wave. So first I'm going to deploy the system. So I have another sync project. This just handles everything that's using in the sync repository. And it's going to go deploy the system out. And then afterwards, once that's done on sync wave 2, it's going to deploy out the resources, which is this one. So this is where I configure stores. You can do external secrets in here. I also put the Vault CA, the CA secret to my Vault in here. Let's see. So I think, yeah, we're good on the deployment. So let's go over the resources now. So I have this demo store that we added. And what it's going to do is create a secret store named demo that we can reference to pull secrets out of. And it's going to connect to my vaults, and it's going to use this secret at path platform. So this mount. And it's a KV v2 mount, so you just put version v2. And then for the CA provider, I didn't want to have to put a base64 encoded huge string in everyone, so I just made a secret for my Vault CA, so Vault CA secret, and then I put that here into this value, and it's going to read it out of here. So I think that's the best way to do that, so you don't have to keep rewriting it everywhere. And then I specify it is in the Vault namespace because I'm making a cluster secret store. This will be available to every namespace to use. And then from here, I'm going to give read-only access, and the mount path is going to be Kubernetes, or the Kubernetes mount path platform. So it's going to use this one with this configuration, and it's going to give this read-only role, and the service account it's going to use is that token reviewer that we use. So it's going to use that token. I found I didn't need this, but you can add the token directly if you need to. I didn't have to do it though. And then from there, we need to get these values into our vault. So to make this a lot easier, I am using Terraform for Vault. So I can just set it up here. Provider vaults, I put in my vault address, I'm just using my vault token as an environment variable, so I'll show you how I can do that. Let me get to my vault CLI down here. So from here, I'll just say vault login method equals OIDC. So this is going to sign me in. Give me a temporary token. I'll block that out. So clear that. We're authenticated. So now, instead of Terraform, I'm just using Tofu, but these are completely interchangeable. So you're going to run an init command, and then I'll just run a plan. I shouldn't have any changes to make. Yeah, so no changes. And so what I did is I made these modules. So the first one is I made this module for setting up a K8s backend. So we'll open that up. And it's very simple. All it does is create the Kubernetes mount, adds your Kubernetes CA, the token reviewer JWT, and then creates an access policy. So it should be the path dash access. So if I look in my vault policies, I should see, yeah, platform access. And it just allows me to log in at that platform mount. And then I have another module I made for a KV mount. And this, you don't have to use these, but it just makes it nice because I can configure the mount how I want. And then I can create some default policies on it. So I can make an admin policy, a read-only policy, an operator and an operator policy. So that allows like updating. So, and it's going to output those in the mount so you can reference them in your files. So like, yeah, here I create it and I add in my Kubernetes host. This can be a DNS name or the IP address of the Kubernetes API server. And I supported doing a file path, which it'll read it in from file, or you can do it inline. So I did it inline, and I just kind of read that in from files ca.crt. So which means I have my Kubernetes CA as a file right here. And to do that, you can just get it out of your kube config. So I do believe I have a command for that. Yeah, right here. So you can cat out your kube config, and then you're just going to run it through grep, and then you're going to format it a little bit, base64 decode it, and then it'll put it right in this file. So you can see that there. And then we also need to get this token reviewer token. So you can also run this command, and it's going to grab, let me zoom in, this command right here, and it's going to grab the secret. Of our token reviewer token. And then it's going to just, I don't want to expose my token. So then it's going to just get the token value out, base64 decode it, and it'll put it into this token reviewer token file. And you can copy that out. And then you're going to create this platform auto.tf vars, which I have right here. And this will automatically load in as variables. You can do this a different way. Like if you're doing it through a pipeline, you can add it to the pipeline variables if you want. But I then add your token here. So then now our token, which from here is set up, and then our CA is added. I found that I didn't actually have to use the reviewer JWT. I think if you don't specify it, it will just pass through whatever token is being used. So you can set it specifically to always use this token, or you can have it be kind of dynamic like that. So for this one, I'm just left it dynamic, so it'll just pass the token through of whoever's making the request. And so once this is all set up, and I'm referencing my module v1, so I made a tag release of that. And then this is going to output some of the roles I need. So it's going to give me my backend path. I can reference it like this using Terraform. I'm going to just allow it to any service account for right now. It makes it easier instead of creating a boundary. And then we're always going to add the default policy. And then you notice here, I'm adding that access policy. But I also want to be able to read some secrets out. So let's make a mount. And I'm going to use my mount module. And then I'm just going to call it platform. And it's going to be a KVV2. And I'm just going to give it a path and a name. And then so back in our auth method we're making here for this read-only rule, I'm going to reference the read policy out of there and just add that in. So now it should be able to have read-only access to everything on that mount. And you don't have to do it for everything. You can create custom policies that manage it. Like, you know, you can create your own different policies. It's very easy to do. And then let me get back to here. And then, so what we do in this case is we're going to apply. And then it says no changes, but you can see I just barely applied this stuff. So I have this read-only role. And then if I look at platform read, let's go check this policy out. Platform read. It shows anything under the platform mount I can read or list. So, makes it easy. And that'll allow data and metadata. Because normally you do platform data star, platform metadata star, but this should just work for all of them. And then, since now we have all that set up, what we do is we go to Argo CD. I would push this up to my repo. If you're not using Argo CD, you would just apply these resources and do the Helm install, which I do believe I've added the Helm install. Where is it at? Yeah, right here. So you can use the Helm install. That'll work just as well. And then you can just use kubectl apply-f these files. For me, I have them all in a repo. So I have a master sync and I just refresh it. It should already be good to go. And then that'll go. And then what that'll deploy out is, let me look up my external secret operator. So I have the system sync. So this is going to deploy that token reviewer token and everything in system. So let's go back here, secret system. So it's going to deploy all these resources down here. And then we can see them pop up. So I have the ESO system right here, and that creates its own project to manage it. So here's the Helm deployment, all the CRDs, everything that went out. You can check the pods. I added the Bitwarden SDK, so you don't have to do that if you don't want to. Feel free to skip that. That's just, I wanted to do something with it in the future. And then, so what we can see here is it made this token reviewer token. So we can see it has the CA, namespace, token, perfect. And then we have the, here's the token reviewer cluster role, the token reviewer service account, and that's kind of all we need in here. So then it will deploy out the resources. So this is what we're looking for. So it should deploy out this demo resource, and then it should say store validated. And then from there, it'll create this demo secret. Oh, we have to configure this. So now let's look at the actual secret. So how do we use the store? You can ignore these annotations. So let's see here. So I'm going to set a refresh interval. So every 15 seconds, you can change this. It's going to update the secret. And so I reference my secret store demo. And it's a cluster secret store. And then this is the name of the secret that I want to make in Kubernetes. So it's going to make a secret named demo in the Vault namespace. And the creation policy owner means if it doesn't exist, it will create the secret. And then this is going to be the key of the secret. This is going to be the path. So let's check this out. So it's going to create this path demo. And then you see I have a key here. So the property, I know that's kind of confusing, but the property is foo. And then so what this means is in the new secret it makes, it's going to create this for me, foo bar. So just to make sure that works, let's say kubectl get secrets -n vault. And then we can see that here, demo. So let's get demo. And then let's just do it to YAML. And then where is the data? Oh, here it is. So foo, and then it's going to base 64 encode it. So bar. Bam. It's annoying, but yeah, you can see bar Brock. So that is how we can use it. And how I've been able to do this in other namespaces is, let's say I have some metric stuff like Loki. So now I can do this storage secret. Let me make this bigger. So now I have this Loki storage secret. In this namespace, I can reference a cluster secret store, give it a refresh interval, and then I tell it, hey, this is the name of the secret I want you to make. And for this key, this is where that secret value exists. And then for this key, this is where that secret value exists. But what's even cooler is, like, in your runners, you can also make a registry cred secret. So you can use this as a template, and then you can change the target name for what you want it to be. And then it will create this Docker config secret and use the username and the token. So here's the reg cred token. Here's that key I make, the username key I make here. And then this will go out. Ooh, I have an error. That's probably why it wasn't working. So it'll get the property username and the token out of Vault and then create this Docker config. So really awesome way, because this is all secure. It's declarative. I'm not risking sharing any secrets with anybody. I can commit this to a Git repo. I can roll it back, have version control. So this is the way you guys should be managing your secrets in Kubernetes. Vault is not the only provider. You can set this up with the GitLab CI variables, which is kind of a cool way of doing it. And you would just have to add a token, a GitLab token secret in for the store to use. There's all kinds of different ways. You can use Bitwarden, which I want to do in the future to check out. So this is just a really nice way to manage your secrets. And if you kind of deploy this on your cluster first, this external secret operator, it makes it really easy to add into any other service that needs secrets. And then if I want to update this, so let's say I want to update it from bar, I'll just create a new version, change it to Baz. Show you that. Bam. And then let's check. Every 15 seconds it should update. So we're going to get this value, foo. But I need to get the raw value. And then let's base 64 to code it. Oh. And it's Baz. I didn't even have to make any changes at all. In 15 seconds it updated. My secret's updated. If I changed it anywhere else, it's good to go. So best way to manage your secrets. Let me know how you guys like this. If you guys like to see more videos, like if you want to see how I have this OIDC set up in Vault. Let me log out. You know, do you want to use this with your own provider? I also have it working with the GitLab provider. I think I need to log in with an admin role. I can show you guys how to do this kind of stuff. Oh, it's an invalid role. I forgot what I had for this one. I'll have to fix it. Let me know if you want to see how to set up Argo CD, how to set up a Kubernetes cluster, Let me know what you guys want to see. Leave some comments on the video. Reach out if you need some help. Like I said, I have a full guide that I went over in the video for deploying all this, as well as some other guides in my docs pages. I have this thing called local cloud, so you can kind of create your own local cloud. This assumes a local host, single node Docker host, but you can put it on a VM, give it an IP address and a DNS name, kind of go through everything. Portainer, here's a vault setup, and I do, as a bonus, have the GitLab setup with OIDC and how to set that up and get it to work. And then how to log in with the CLI, how to use GitLab JWT, use it in the CI pipeline. So feel free to check out my repo. I have lots of stuff in here. OpenTelemetry, Prometheus. How to, if you want to deploy a Citadel OAuth like I have kind of a starting point for it, but I'll make a video on this in the future. So thanks everyone, appreciate your time. Sorry it's been a while to make a video, but more is coming.